All right, so now we're going to learn about the dot product, which is another operation thing with vectors, basically. So we want to understand what the dot product is, its properties, and its uses, and why we care about it. Before we do that, we want to refresh ourselves on vocabulary. These are words we have used already this unit a lot. Scalar. Raise your hand if you can tell me what scalar is. No? All right, disappointing. So a scalar is just a real number. I know, you knew that. How about a vector? Anyone? Vector? Vector? What's your vector, Victor? That vector? Old reference, lost on young viewer. Ah, man, it's tough when you're just by yourself. Can't even write words correctly. Just kind of talk, write, talk amongst yourselves. Yes, that's what you want. Directed line segment, that's what a vector is. So just like with derivatives, we have to think about what is the application of a derivative. Derivative is the slope of a tangent line to a function anywhere on the function. What is a vector? A vector is a directed line segment. That means it has direction to it, but it means it's a segment. Excellent. Moving on. Law of cosines. What does the law of cosines lead to? Well, if I have some vector u and some vector v and then some vector u minus v. So let's draw this picture. So I'm going to say that this is vector u. This is vector v. I have some angle alpha in between them, and then I have vector u minus v. So what do I know about these using the law of cosines? We actually saw this earlier on in a warm-up. So I know that magnitude of u minus v squared is the magnitude of u squared plus the magnitude of v squared minus 2 magnitude u times the magnitude of v times the cosine of alpha, right? That's our law of cosines. So if we actually write this out, let's look and see what we get. All right, so the magnitude of u minus v squared is x1 minus x2 squared plus y1 minus y2 squared. Magnitude of u squared is x1 squared plus y2 squared. Magnitude of v squared is x2 squared plus y2 squared. And then this part stayed the same. So now we are going to reduce a little bit. So I see that if I was to multiply this out, oh, let's use a different color. X1 squared minus 2x1 x2 plus x2 squared plus y1 squared minus 2 1 squared minus 2y1 y2 plus y2 squared equals x1 squared plus y1 squared plus x2 squared plus y2 squared minus 2. You ever get lost talking to yourself? Magnitude u, magnitude v, cosine alpha. Me neither. Cross things out. x1 squared, x1 squared, y1 squared, y1 squared, y2 squared, y2 squared, x2 squared, x2 squared. Notice that everything has a coefficient of 2 and negative. So I have negative 2x1, x2, negative 2y1, y2, negative 2, magnitude u, magnitude v, cosine theta. Divide everything by negative 2, and what do I end up with? x1, x2 plus y1, y2 equals magnitude u times the magnitude of v times the cosine of alpha. Why do I care about this? Excellent question. Really? It was just 5 minutes of both of our lives that we can't get back. Yeah, so. But we care about it for this, because this is going to lead us to the dot product. So that part right there of the law of cosines, the x1, x2 plus y1, y2, is what we call the dot product. So this is what we call v dot w. That is not multiplication. Dot product. DOT. TOD is spelled backwards, but DOT is dot. This is the dot product. What it is if I have two vectors and I multiply their corresponding components and then add those results together, I get what I call the dot product. So the dot product of two vectors is the sum of the products of their horizontal and vertical components. Why did we care about all those definitions at the beginning? By all of those, I mean two of them, because we want to understand the dot product is a scalar. It is not a vector. It is just a real number, or a number, but it'll be a real number because it's a scalar. That's what the dot product is. So I want you to find the dot product. So if you're given v is 5i minus 2j, w is negative 3i plus 4j, I want you to find v dot w, w dot v, w dot w. Pause the video, unpause when you're ready to check. All right, so v dot w and w dot v should be the same thing because they're both scalars. So v dot w is 5 times negative 3 plus negative 2 times 4, which is negative 23. W dot v is negative 3 times 5 plus 4 times negative 2, which is also negative 23. What's w dot w? W dot w is negative 3 times negative 3 plus 4 times 4, which is 25. So another thing I want to point out, since we're here, is notice that w dot w is the magnitude of w squared, right? Makes sense. Okay, moving on. Properties of the dot product. If I have u, v, and w, they're all vectors, and c is a scalar, then u dot v equals v dot u. We just saw that on the last example. U dot v plus w is the same as u dot v plus u dot w. 0 dot v is 0. V dot v is the magnitude of v squared. We just talked about that. And c times u, where c is the scalar, dot v is c times u dot v, or u dot c times v. All of those will be the same. Another way we can write the dot product, think about back when we did our law of cosines at the very beginning. Back to that. That was fun. Remember that? We had x1, x2 plus y1, y2 equals magnitude u, magnitude v, cosine alpha, where alpha is the angle between the two vectors. So this is the dot product. So I can also set it equal to magnitude u, magnitude v, cosine alpha. So this is what we call the alternative form. So if u and v are two non-zero vectors and theta is the smallest non-negative angle between them, then v dot w is magnitude v, magnitude w, cosine theta. Another way I can write this, so this is another way to find the angle between two vectors, is I know cosine theta is going to be v dot w over magnitude v times magnitude w, or theta equals cosine inverse of v dot w over magnitude v, magnitude w. So I want you to find the angle between v when it's 2i minus 4j and w when it's 3i plus 2j. Pause the video. Unpause when you're ready to check. All right, so cosine inverse of 2 times 3 plus negative 4 times 2 over the square root of 2 squared plus negative 4 squared times the square root of 3 squared plus 2 squared. So then the cosine inverse of negative 2 over the square root of 260, and this becomes 97.125 degrees. So one thing I want you to think about is in this alternative form, what would it mean if the dot product came out to be 0? What would that tell us about the relationship between the two angles? I'm sorry, not between the two angles, between the two vectors. So if vector v dot vector w equals 0, what does that tell us has to be true about v and w? Think about that, because that's actually going to lead us to the next video. But in general, with the dot product, conclusion, make sure you understand how to find the dot product and that it represents a scalar and that it is the product of the horizontal components and the vertical components added together.